Good morning, Math 146/046. I want to just recap today. Really glad we spent the day sort of slowing down and talking about linear regressions and making predictions. I want to summarize just the most important takeaways for everyone that was there and for those who were not. I'm going to start just by showing this was the warm-up question, which really ended up being the question we talked about in class today. About the Columbia River salmon. So I'm going to open this data set in a second. But in class, basically in class last week, and then on Monday, and then on Tuesday, all 3 days, we were in StatCrunch making these linear regressions and scatter plots. So this particular question has to do with salmon, and it's all about salmon count over various years. So like a lot of models, the X variable is going to be measured in years after a certain time. So they started counting salmon in the Columbia River in 1957. So that would mean we'd basically call the year 1957 the year zero, the start of our model. And the year 1958 would be year one, 1959 would be year two, and so on and so on and so on. And this particular data goes all the way, it has 43 values. So this really goes to 1999 is the year. And notice that if you do 1999 minus 1957, you get 42. So the X value is measured in years after 1957. So just going to bring this up. Stat, this is a regression, meaning make a line that sort of summarizes a two-variable data set, simple linear. And if we select years after 1957 as our X and adult spawners, those are the salmon count along the Columbia River at a certain location and get the compute. Before I show you the summary, I'm just going to show you the graph. So what we're looking at is years passing between 1957, the year zero, and 1999, the year 43, for X equals 43. And you can see that in general, this shows a negative trend, whereas the years go by, the salmon count is going down. And that's sort of, as you read this left to right, you see that dropping of the line, which somewhat matches the data. So notice if you float over that red line, it just pops up the equation, 7265.2156 minus 174.81426. That refers to the red line, which means for any value of X, so if X were 20, that would be the year 1977, 20 years after 1977. If you plugged 20 in for X and did that calculation, you'd get the predicted salmon count for that year for 1977. Okay, so just pointing that, we can see that the data does, you can see the trend. So you can expect this is going to have a moderate to strong linear relationship because it seems to make sense that a line would capture the trend going on. So just going back to that, that's the same, this is the same equation that was just displayed without the letters X and Y in it, but we'll talk more about that. The only other place you need to look on this is that the correlation coefficient is 0.78466, so on. So I'm going to switch back to that Word document and just go, one of the questions after generating the line, the first question said, write everything you can about the relationship between these two variables. And the R is about negative 0.785, or I like to think of that as 78.5% correlated in the negative direction. So that's pretty strong, as in if the time passing, it really does a decent job explaining the changes in the salmon count and predicting the salmon count. So there's the equation. I'm going to simplify it for the purpose of this, just not to have so many decimals. That's just rounded numbers, 7,265.2 minus 174.8. So 7265.2 would be the predicted count for the year 1957. And then every year after that, you're seeing this drop of salmon, approximately 175 per year. And that's that minus 174.8. And just to remind you, both between the number 170.8 and years after 1967, or between that number in X, there's multiplication happening there. Okay. Feel free to follow up with questions if there's something you wish I had just gotten into, but I didn't just now. But I'm trying to do a reasonably brief summary of what we talked about today. So I'm going to switch over and just say, what does your linear regression predict for the number of adult spawners in the year 2024? So the first thing I'm going to say is that 2024 is X, remember, is years after 1957. So my X value in this case is going to be our current year of 2024 minus that 1957 year. And this is going to end up being, let's see, 50 plus another 50 years, 60 years, or 50 years gets us to 2007, 60 years gets to 2017. So it ends up being 67 years. So X in this case would be 67. And feel free to pause the video and confirm that calculation. So if we look at the equation, which was predicted value, start with 7265.2, and then subtract 174.8 times whatever your X value is. Well, we're going to just use that value of 67 for that X right there. So this is going to tell us a prediction of the population based on this formula would be 7265.2 minus 174.8 times 67. I'm going to do that calculation real quick. And if you got this calculator, which is the one I recommended for the class, you should be able to just enter that as exactly like you see it. 7265.2 minus 174.8 times 67. And let's see if this gets it. You might see it'd be too small, but I just wrote it exactly like that. My calculator. And you may think your calculator made a mistake, but it didn't. Y hat equals negative 4446.4, which you'd say, how can you have a negative salmon count? And you can't. So the reality is probably that would be 0. I'm going to peek back to that graph just to explain that number. So if we look back to the graph of our function right here, notice that it's basically already at 0 by the year 1999. And then it just continues down and down and down and down. So it makes sense by the time we went from 40 to 50 to 60 to 67, this line is getting down into the negatives. And if you imagine if that's positive 5,000, negative 5,000 would be down here. And it makes sense that that line would hit that. Someone in class said, well, I'm just going to call that 0. And I think that makes sense. So switch back to the Word document. So even though that's a kind of a nonsensical answer, it makes sense because basically it was saying that the salmon count was getting to 0 way back in 1999. So if it keeps dropping by 175 each year, it just starts to dip into the negative. The second question I asked people to calculate was, when does the linear regression predict the adult spawners count will reach 0? Well, that 0 is an adult salmon count. So that's really a Y variable. In fact, it's a predicted, when do we predict that Y will be 0? So you'd use the same equation, but you would just plug in 0 where we see the Y hat above, right there. So 0 equals 7265.2 minus 174.8 X. And the X is the unknown in this case. To solve this, it's a two-step problem. We're going to first subtract 7265.2 from either side. And that's a pretty easy calculation. We can just do 0 minus that number. It's just going to give us exactly what we see, negative 7265.2. But on the right side, that number is just gone. So we're left with that subtraction of 174.8x. And then the last step of this would be, since this is multiplication that attaches that 174.8 and that x, we're going to divide by exactly that 174.8 on either side in order to solve for x. And that I will use a calculator for. I'm talking about negative 7265.2 divided by negative 174.8. And that gives us a positive answer, which makes sense because we did a negative divided by a negative. And I'm going to round it to about x is approximately 41.6. It's actually 41.56292906, but that'll round to about that. So, so that would be how many years after the start, after 1957. So you could kind of think of that as years after 1957, but we don't usually say that. We don't count things. We don't talk about time in terms of years. So if we literally just added that number to 1957 to figure out what year that was, 40 years after that will be 1997, 41, 1998. So that ends up equaling 1998.6. So somewhere in the year 1998 is where that count reaches 0. And again, if we look back to that graph, that makes perfect sense that here we are, the year 0 is about that height right there. That, yeah, look, here we are at 40 something. So 41.6 makes sense as a perfect spot for that thing to hit 0. That is where I need everyone to be starting tomorrow. Remember, you can rewind this video and watch it again or pause it so you can calculate along the way. But these skills of looking at two variables, describing their relationship in terms of correlation, and sort of using this equation to make predictions for either the X or Y variable are all going to be things that are covered on your test next week, and just general things that you're expected to know leaving the statistics class. So hopefully this is helpful. Certainly probably for people who weren't there today, but hopefully for the ones that could use a little solidifying after leaving today. So I will see you all in the morning.